morning friends. In kinetic theory, we discussed about the ratio Cp upon Cv. That means the two specific heat at constant pressure and constant volume. This ratio we obtain for different type of the gases, like as the monoatomic gas, diatomic gas, triatomic gas, and also for polyatomic gas. Now, after the discussion of this, now what is the specific heat for solid and also for water? Or what is the value of specific heat for solid and water? For that purpose, first we discuss about derived equation of solid specific heat capacity of solid. We are interested to derive the equation of the specific heat capacity for solid. For that purpose, in solid, the atom oscillate about their mean position. Now listen. How many independent motion possessed by the molecule of the solid? Only the vibrational motion. Linear motion and rotational motion does not perform by the molecule of a solid. Because in solid, the intermolecular forces and also the separation or the distance between the molecule is very small. Therefore, the molecule of a solid only possesses the vibrational motion. Therefore, in solid, atoms oscillate about their mean position only. Suppose the number of atoms in one mole solid are in A. We assume that in one mole solid, the number of atoms is equal to the Avogadro number N. And energy associated with oscillation of atom in one dimension. So the molecule of the solid particle can perform the oscillation. That is the formation of the solid. So this solid can perform the oscillation about their mean position only, this way. Right? Therefore, the energy associated with the oscillation of single atom in one dimension is the 2 into half kBT. Half kBT is the energy associated with each independent motion or each degree of freedom. So each degree of freedom is half kBT. Here the two different type of the oscillation performed by the molecule of a solid. Therefore, 2 into half kBT is equal to only kBT. Again, in solid, the atom oscillate about their mean position only. No linear motion, no rotational motion. Only the oscillation about their mean position is possible in solid. Number of solid in one mole. In solid, the number of atoms in one mole is suppose the Na Avogadro number. Therefore, from law of equipartition of energy, the energy associated with oscillation of an atom in solid in one dimension is 2 into half kBT is equal to kBT. Right? So, in one dimension, it performs the oscillation in this way. Two possibilities along the x-axis. Therefore, 2 into half kBT is equal to kBT. Now, in 3 dimension, the average energy associated in 3 dimension, that is along the x, this way the molecule is also oscillate about their mean position along the y-axis and also along the z-axis. Therefore, in 3 dimension, the energy associated with or the average energy of atom is equal to 3 times of this, therefore 3 kBT. 3 kBT. Therefore, the total energy of one mole solid is equal to U is equal to 3 kBT into Na. Na is the number of atoms in one mole solid. But we know that Kb into Na is equal to R. Therefore, internal energy is equal to 3 RT. Kb into Na is equal to R. Therefore, 3 RT. Again, keep in mind that our concept about the solid must be clear. At that time we can calculate this internal energy of molecule of a solid. Keep in mind that in solid, the atom only perform the vibrational motion or the oscillate about their mean position. Clear? Also in one mole solid, the number of atoms is Na. Number of atoms is Na. Or in other words, suppose the number of atoms in one mole solid are Na, and energy associated with oscillation of atom in one dimension. In one dimension, either along the x-axis, it performs the oscillation like this way. Therefore, the 2 degree of freedom, therefore 2 into half kBt. Half kBt is the average energy or the energy associated with each independent motion. So half kBt from law of equipartition energy. So 2 into half kBt is equal to kBt. But in solid, the molecule of a solid or the atom of a solid perform the vibration in 3 dimensions along the x-axis, y-axis, and also the z-axis. Right? Therefore, in 3 dimensions, the average energy of atom is 3 kBt. So one atom has the average energy is 3 kBt according to this. That is in 1 dimension, that is in 3 dimensions, that is the total average energy. Therefore, total energy of 1 mole solid. 1 mole solid. In 1 mole solid, the number of atoms are Na. Therefore, 3 kBt into Na, but we know that kB into Na is the universal gas constant, therefore 3 Rb. So in short, first we obtain the energy for one atom. In 1 dimension, then 3 dimension, and then the energy of 1 mole solid. Okay. Now, in the first law of thermodynamics, delta Q is equal to delta U plus delta W. Delta W is the work done. Work done delta W is equal to P into delta V. P into delta V. At constant pressure, the change in volume. For a solid, the change in volume is almost 0, therefore this term is 0. For a solid, the change in volume is 0, therefore whatever the change in energy is transferred into the change in internal energy of a solid. Again, the change in energy or the exchange of the heat is transferred to the change in internal energy of a solid. Therefore, delta Q is equal to delta U. Delta Q is equal to delta U. Again, from the first law of thermodynamics, delta Q is equal to delta U plus delta W. But delta W is equal to P into delta V for the isothermal process. Okay. But for solid, delta V is equal to 0. Solid cannot be compressed. Therefore, work done is 0. Therefore, delta Q is equal to delta U. That means the exchange of the heat is transferred to the change in internal energy of a solid. Now, from the definition of molar specific heat. Molar specific heat is, what is the definition? The amount of heat required to change the temperature of 1 mole of solid by delta T is known as the specific heat of a solid. Again, the amount of heat required to change the temperature by 1 Kelvin or the 1 degree centigrade of a solid is known as the molar specific heat. Again, I repeat the definition of molar specific heat. The amount of heat required to change the temperature of 1 mole of solid by 1 Kelvin or the 1 degree centigrade is known as the molar specific heat of solid. We discussed about this definition of specific heat in chapter 13 thermodynamics. Therefore, C is equal to delta Q upon delta T, but from equation 3, delta Q is equal to delta U, therefore delta U upon delta. For small change, we can add the du by dt. Therefore, d by dt as it is, value of U is 3RT. 3RT. 3R is constant, taken out, dt upon dt is 1, therefore 3 into R. Value of R, universal gas constant, is 8.31 joule per mole Kelvin. Therefore, 3 into 8.31, that means the 24.93 joule per mole into Kelvin is the value of specific heat capacity for a solid. 1 mole solid. Clear it? Okay. Again we repeat it, that is the quite different here. And same as for water we are going to derive. But here our concept about the solid must be clear. In solid, the molecule of a solid does not perform the linear and also the rotational motion. The molecule of solid only oscillate about their mean position in 3 dimensions along the x-axis, along the y-axis and along the z-axis. So in short, we had to first obtain the equation of the energy of one molecule. First in 1 dimension, then 3 dimension, and then the energy of 1 mole of solid. For that purpose, in solid, atoms oscillate about their mean position. Suppose the number of atoms in one mole solid is in A. Therefore, energy associated with oscillation of atoms in 1 dimension is 2 into half kVt. In 1 dimension, the particle perform the oscillation along the x-axis, that means 2 different independent motion. Therefore, 2 into half kVt. Half kVt is the energy associated with each independent motion. So 2 by 2 is cancelled, so kV into T. Therefore, in 3 dimension, the average energy of atom is 3 times of this, so 3 kVt. That is the energy of one atom in 3 dimensions. Therefore, the total energy of 1 mole solid is U is equal to energy of one atom into number of atoms. 3 kVt into Avogadro number. Na into kV is our universal gas constant R. Therefore, 3 RT. That is the equation 1. That is the average energy of 1 mole solid. Okay. Now, the first law of thermodynamics, delta Q is equal to delta U plus delta W. Delta W is the work done. Work done is equal to P into delta V. Therefore, delta Q is equal to delta U plus P delta V. In case of a solid, the change in volume is 0. Therefore, delta Q is equal to delta U. That means the exchange of the heat in solid is only cause the change in internal energy of a solid. Now, from the definition of the molar specific heat of solid, definition of molar specific heat of a solid is that the amount of heat required to change the temperature of 1 mole of solid by 1 Kelvin or 1 degree centigrade is known as molar specific heat of solid. From definition, C is equal to delta Q by delta T. But from this equation, delta Q is equal to delta U, therefore delta U upon delta T. For small change, that is the du by dt, substitute the U as 3 RT. Therefore, d by dt of 3 RT, T is 3R is common, dt upon dt is 1, so it's equal to 3 RT. Therefore, C is equal to 3 into 8.31, therefore 24.93 joule per mole into Kelvin. Okay. Now, the same equation we are going to derive for the water molecule. Now, water molecule is consist of the 3 atoms, 2 of hydrogen and 1 of oxygen, vibrate about their mean position. Okay. Now, the energy associated with oscillation of one atom in 1 dimension, the same as 2 into half kVt is equal to kVt. First, we obtain the energy associated with only one atom in 1 dimension. So it performs the vibrational motion. Therefore, 2 into half kVt therefore kBt. Now in 3 dimension, energy of one atom in 3 dimension is equal to 3 kBt. And therefore, total energy of one molecule of water is 3 into 3 kBt is equal to 9 kBt. 9 kBt. Because the one molecule is consists of the 2 hydrogen plus 1 oxygen atom. So in one molecule already the 3 atoms are present. Here also the water molecule does not perform the linear and also the rotational motion. It only performs the oscillation about their mean position. And due to that reason, first we find out the energy associated with the oscillation of one atom in one dimension. One atom performs the oscillation in one dimension is 2. Therefore, 2 into half kBt. Half kBt is the energy associated with each independent motion. 2 to cancel, therefore kBt. In 3 dimension, that atom performs the oscillation in 3 dimension, therefore 3 kBt. But water molecule is consist of the 2 hydrogen and 1 oxygen atom. That means the 3 atoms. Therefore, the total energy of one molecule of water, 3 into 3 times 3 kBt, that means the 9 kBt. And now the energy of 1 mole water is equal to 9 kBt, that is the energy of one molecule, into number of molecule in 1 mole water is Na. Therefore, 9 kBt into Na. Kb into Na, that is the universal gas constant, therefore 9 RT. 9 RT. The same as delta Q is equal to delta U. Now, from definition of the molar specific heat of water, so C is equal to delta Q upon delta T. Delta Q is equal to delta U, therefore delta U upon delta T, and for small change, du by dt. Therefore, d by dt, value of U is 9 RT. 9R is common, therefore dt upon dt cancel, therefore only 9 into R. So the specific heat of water 9 into R is equal to 9 into 8.31. That is the value of universal gas constant 8.31 joule per mole Kelvin. Mole into Kelvin. So that is the 74.79. Again for water molecule is consist of the 2 hydrogen and 1 oxygen atom. For that purpose, first we obtain the energy of 1 atom of water. Therefore, the energy associated with oscillation of atom in 1 dimension is 2 into half kBt is equal to kBt. In 3 dimension, that is 3 times. Therefore, energy of 1 atom in 3 dimension is 3 kBt. Now, the molecule of water is consist of this type of the 3 atom. Therefore, total energy of one molecule in 3 dimension is 3 into 3 kBt is equal to 9 kBt. And thus, the total energy of 1 mole of water, U is equal to 9 kBt into Na. Na is the number of water molecule in 1 mole water. Kb into Na, universal gas constant R, therefore 9 RT. Okay. Now, from the definition of molar specific heat of water, C is equal to delta Q by delta T. Already we know that delta Q is equal to delta U. Therefore, delta U upon delta T. For small change, du by dt. So, d by dt and value of U is 9 RT. 9R is constant taken out and remaining is dt upon dt, that means the 1. Therefore, C is equal to 9R. Now the value of R is 8.31 joule per mole into Kelvin. Therefore, C is equal to 9 into 8.31. Therefore, 74.79 joule per mole into Kelvin. There is, so that is the specific heat capacity of water. 1 mole of water, and that is for solid. So here the theory portion of this chapter, kinetic theory, is completed here. Now we calculate the numerical.